So I pulled out three major trends and I put them all under this umbrella called agentic friction. The most obvious is dependency hell. You're dealing with a bunch of different model providers that have their own API. You're working with open source libraries that might be introducing breaking changes. You're also working with startups and vendors that might be doing a rug pull on you. The other one is this never-ending integrations that is happening. Every framework will have their own learning curve associated with them. You end up in this state where you're constantly tweaking, constantly hacking. And through that tweaking and hacking, it might be fun, but as a professional person, I want to get a good night's sleep. So the last piece here is skill issues. And not in a condescending sense of where like it's a skill issue, go figure it out. The education path for agentic engineering or agent flows is it's really we have A to C, right? We have those first three steps. We can get people started and we can get them on the path towards autonomous agent. But from like C to Z, like that final place where this is full autonomy or what people are calling production, it is not clear yet. There's just so many different windy paths to it, and it's not clear what the definition of this is as well. It's really tough to get agents into a state where their behavior is really predictable because inherently their behavior is not predictable. That's kind of the power behind it. And you, as someone who's developing agents, you're going to have to develop a skill set around making sure agents are actually reliable. And that comes down to a really familiar pattern here that I'm calling the AMU pattern. Now, I don't want to take too much credit for this pattern. I kind of just put a name on it, but it's based on a couple of trends that has happened over decades at this point. The first thing I want to call out is this use of adapters. You should be familiar with adapters. If not, adapters are basically things that live on the outer edge of your unit. And these adapters do two things well. One, there's a driving adapter, and then two, there's this reactive adapter. So the driving adapters, I call them primaries. The reactive adapters, I call them secondaries. The primaries deal with events, requests, and commands. So anything that's like do a thing to an agent. And then the secondary adapters deal with all the other stuff. So other AI runtimes, other agents, data stores, vendor specific technology, even queues. Most of the time, I spend a lot of time here because this is where all the integration work is. But being able to isolate it does a couple things. It's modular, it's simple to test, it's granular. There's a simple integration refactor path. I only have to make updates here. I don't have any framework dependencies. And what I mean is there's no framework dependencies in my metadata and my use cases where like all my business logic lives. So this doesn't depend on a specific type of language. You can always just write code that encapsulates your metadata. You can write code that encapsulates your use cases, and you can write code for your primary adapters and secondary adapters. So why am I talking about this pattern? Well, you'll see that the major frameworks is a hint that this is coming down the pipe where people are no longer doing agent to agent invocation or agent to agent communication. They're trying to give people the tools to take their code that they've written in maybe a notebook or a CLI and have them go into production environments. And so they're introducing Llama Agent specifically is introducing the idea of a service, a message queue, a control plane, and an orchestrator. These are all concepts from microservices and distributed systems. LangChain is also introducing LangGraph, which helps you manage control flow of the agent calls. But they also have a couple of other components too, where they're bringing you up all the way to the LangGraph cloud, and they're implementing Langsmith, which does a lot of the metadata management and the monitoring that you would need in a real commercial solution. And if we look at the trends from 2022 to 2024, let's start with 2022. So if we were to do a little bit of quick math, we'll say that the agent development space is about 2 years behind the majority of software development. So there's just a little bit of catching up to do. I'm sure this is going to happen quickly as a lot of software developers are going to be interested in AI. And so they're just going to bring these practices over as they start building out tooling for the different workloads and the different use cases. The modular monolith is on its way up at this point in 2022. And then also the actor model is on its way up as well. You also see serverless is on its way up too. So a lot of concepts were kind of brewing right before ChatGPT let loose large language models on the world that is really impacting how agents are built right now. If we go into 2023, one thing I'd call out here is that design makes a bit of a surge in the early adopters in 2023. As people started figuring out a lot of this stuff, you can see that design is becoming more and more important. Now, when we move into 2024, I think a lot of the design got folded up into architecture because it was just easier to put it there. And large language models moves into the early adopters phase as well. So the maturity of the software development space is pretty well established. It's just that agents are going to have to start taking advantage of this stuff. It's probably going to enter in at 2025, either here or here, depending on how fast things move in the next couple of months. Okay, so back to the AMU pattern. I'll kind of give you a hint of where I got this from. So I read an article like a year ago about this, and it was from a CTO. He was talking about the fact that the traditional software development routes for enterprise are just so heavy. It takes a lot of time to train people up. It takes a lot of time to get the concepts. It also takes a lot of code. So he came up with this serverless, lightweight, clean code approach, and he's been talking about it for a long time. So I will go check out this article if you want to really deep dive on how this works. The examples are all in AWS CDK and TypeScript, but they're pretty easy to follow along. So as long as you have a good understanding of a basic understanding of distributed systems, you should be fine. Okay, you definitely want to see your practical application of this, right? You're probably rolling your eyes. You're saying, oh, here we go with clean code again. Here we go with domain-driven design again. I really want to emphasize that I'm taking the approach of saying, let's get rid of a lot of this stuff, right? Let's get rid of it. Let's take it out. And let's keep maybe one or two layers, rename this to metadata. So I'm not really doing anything different. And also with domain-driven design, I'm kind of saying get rid of all of it, right? Just keep the services, keep the model-driven, keep the smart UI. And with client-server database, it's almost keeping that idea alive, but not focusing too much on the physical machine, but keeping this idea of different tiers here, right? So with this high-level design, I implemented this in a way where the API, the queue, and the agent all follow this AMU pattern because it just worked for me and I didn't realize it would work so well. The reason it works so well is because you can do these really explicit contracts between these different components in your system, whereas before you might have to write one file that does all this work and you might get lost and confused on how it's implemented 10 months down the line when you revisit it again. With the AMU pattern, although it's a bit verbose, I'm not going to say it's not verbose, it's just clear what's going on, and I'm able to make changes and make updates very, very quickly. Also, it makes it easy to write and read data because you all have metadata throughout the system, and so now it's very clear what's going into your database and what's coming out at any point in time. This is like the vendor neutral approach. I always like to show like the vendor neutral approach because I'll have people in the comments yelling at me for using AWS, but the AWS approach essentially is almost the same. The idea here that I'm going to showcase to you is very simple. I've done it many times on the channel before. It's like my favorite example to do. It's taking a YouTube URL, submitting it to a queue, and then from the queue, hitting an agent. Now, in most examples you'll see today, they're not really talking about how they're doing this on the back end, but I'm imagining this is some of the workflow that's happening today. If you are still working with like directly invoking an agent, just know that this pattern also applies where you just simply break it up. You don't directly invoke the agent. You send an event to a queue and the agent kind of picks it up from the queue. And so on the back end here, when it goes to the agent, and it'll work on creating that piece of content. It'll use Claude in a couple places. It'll actually use the Amazon Bedrock runtime when it does its tool call. And then it'll persist content to Amazon DynamoDB. And on this part here where the user's kind of looking at their content, I wanted to keep it very simple. I don't want to make it too complicated. This is just like a simple request response. So you can start to mix and match different types of workflows here when you're thinking about working with the agent. What you'll notice is the agent is just another component in my system. It's not the entire thing. And that's kind of the point I want to drive home here. And when I'm talking to folks and I'm looking at their projects, the agent's the entire thing. It's like, no, don't do that. They're trying to have the agent write to the database. They're trying to have the agent summarize the text. They're trying to have the agent update another service. They're trying to have the agent respond directly to the API. That's just too many things for the agent to do. Instead, you give the agent a very scoped down set of tasks and then just have it do its thing. But everything else, we have the tools to do it. We have API gateway already, so there's no need to put your agent right at the front of the API We already have something that handles messages. Just use any queue technology out there, send it events. And we already have LLM endpoints where you can work with them directly. So sometimes you don't need to have the agent respond to the task. You can actually send it over to a different LLM. In this case, I didn't send it over to a different LLM. It's just Claude again, but the difference is the reasoning here is Claude 3, and then the actual like generation of the content is Claude 3.5. So it allows you to do a couple different things. Another missing piece you might have in your architecture is you don't have any logging, so you're not privy to what's actually going on in the system. So things like LangChain are trying to solve this. Of course, they have their own logging and monitoring system here. I haven't seen anything from Llama Agents yet, but I might be wrong about that. But yeah, again, 2 years behind in terms of providing all of these types of auxiliary services that can make you production ready. So let's go ahead and jump into the application. And I'm going to like do a quick demo of how this works. And then we can look at a couple of the code snippets on how this actually looks inside of an editor. This is Ghostwrite, where you can repurpose content that you have already on YouTube for downstream platforms like Twitter or LinkedIn. One of the first tasks you can do is actually train your agent, and that is easy. You just pop in a YouTube URL here, hit submit, and then it should give you a notification. Hey, your video is processing. Once it's ready, it'll be available for the content agent. I head over to the content agent here, and I can select that video I just added. Then I can choose up to 3 platforms at a time just to make sure things work correctly on the back end. And then I can give a prompt for each platform. So we'll get to see like how the model handles these 2 different prompts from a single piece of content. That way it reduces the burden on me when I go to post on these platforms. I can just look at these 2 briefs, maybe pick them up, and then actually do the posting. We're going to hit repurpose here. I do have a little thing that says job submitted. It'll give some information to the user about how long it will take. We have our 2 posts that got generated. Let's take a quick look at how the model did. All right, so here's a sarcastic Twitter thread aimed at tech enthusiasts based on the video. Attention tech gurus, feeling overwhelmed by endless sea of AI tools? Fear not, I've discovered the ultimate solution to all your problems, more tools. Oh, it got me there. I thought it was going in the opposite direction. Why settle for a simple workflow? We can have a beautiful, intricate web of point-to-point integrations. It's like playing connect the dots, but with APIs. So much fun. Who needs sleep when you can spend countless hours juggling documentation from 47 different platforms? It's the perfect way to test your sanity. That's pretty funny. Dog hell. I like that. It came up with its own little hashtag. Pro tip, if your tech stack doesn't resemble a Jenga tower on the verge of collapse, you're doing it wrong. The more precarious, the better. That's a big word. Remember, folks, the key to success is to make your workflows so complex that even you can't understand them. It's job security at its finest. That's good. I like that. It actually made me laugh. Maybe my sense of humor is just... Let's look at the takeaways for LinkedIn. So, simplifying complex workflows, the powers of APIs in business. As business increasingly relies on multiple tools, yada, 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 the risk of tool sprawl, okay. 1, consolidate your workflows behind API endpoints. Adopt a definition approach strategy. Leverage managed platforms and GPU-rich environments. Okay, that's pretty much all the stuff I said in that video. If you haven't watched Simplifying Your AI Agents with this strategy, you can go ahead and watch that video up here. I'm going to link it somewhere. The final piece of functionality where you can export these out. So what you can see is it gives us a content ID, which is pretty important. So you can track this throughout your system. A video title, the target platform it's for, and then the actual generated content that we got. Emojis and all. This is not bad. If anything, it saves me a lot of time before going to these other platforms. Instead of trying to sit there and think, what do I post? What do I post? Start with my YouTube video and then simply just post these, tweak them a little bit, add my own voice to it. But it gets me like 80-90% of the way there and just saves me time so I can get back to programming and building out the application itself. All right, so next we're going to go into some of the code around this and talk through the AMU that was used here. Okay, so here is the general structure of how I set up these agents within a like monorepo style, modular monolith, whatever you want to call it. What we have here is the agent plane, and then underneath it is going to be all the different agents. For example, this is just the content agent. We're working with one agent here, and it has a couple of attributes to it, which is the adapters, the metadata, and the use cases, basically this AMU pattern I've been describing. you can call it here. It just has one primary, which is the way it collects all the events off the queue. And then it has a couple of secondaries because it interacts with the actual agent runtime, the buckets, and the data stores that I have set up. And then the metadata, I keep it fairly simple here, so not a lot of people might agree with this, but I just have a schemas folder, and I throw in everything into that schemas folder. And for use cases, there is one use case for now, and that's the generate content use case. So you'll see this is pretty simple, but it's adaptable. Basically, you can do whatever you want within these folders. It's just to really help you organize the way you're thinking. The adapters is for like inputs and reactions, and then the metadata is for structure. And then use cases really is for like logic right here. So next up is the metadata that supports type safety and data transfer throughout the code bases. You want to have some type of structure going into these agents because the workflows are unreliable and hallucination really can creep up in weird places. So just having this extra layer of types and schemas makes it so that your reliability goes up by a major percentage points. There's a bunch of studies coming out right now that just adding types, just adding the structure is going to help your reliability go up. You'll see here I just have a couple of really explicitly defined things, which is like a content repurpose request, an actual command, input event for the agent, the response the agent's supposed to give, the content, the structure of the content it's actually supposed to take in, and then the content output as well. And here we'll dive into like the actual primary adapter where I highlighted before is the content agent. Here the event is coming in, so we have that agent input event. Then we're just kind of parsing it out. Now this is specific to AWS, but the idea kind of remains the same. You have this function name here I'm calling out because I want to make sure it uses the generate content function when that gets passed through in the agent input event. And then that'll signal to the agent, all right, I got this generate content function. What I want to do is use the appropriate use case. And here in the use case, we kind of just fall back to what we're doing in AMU. We use a use case that calls a lot of secondary adapters, but the use case really maps out our actual business process flow. So for the use case, I like to think about it as what would I do in the manual process and then work backwards from there. If you look at the steps here, what we're doing is we're getting that video transcript. This would be like we're creating a prompt. This would be a prompt you would enter into Claude or ChatGPT, basically saying, hey, take this transcript and give me a post for this specific social media platform, for example, X, formerly Twitter. And then we would get a response back from the chatbot and be able to then save that response somewhere, either in like a table or a spreadsheet, or maybe just pen and paper, you'd copy it. And in this case, we're just crafting this piece of content and then saving it wherever we want. And so within the secondary, it's just a function. And within this function, you can do the steps you need that are very specific to the platform's vendor tool. So you see here, I like to use AWS. So I'm using Bedrock specifically. I'm sending a request to the Bedrock runtime, and then I need to process and return that generated content. And that's all specific to Amazon Bedrock. Now, let's say I wanted to change things up and I wanted to use the OpenAI API directly. I can just come into this function right here and then swap out my implementation details. I could also get really fancy with the swaps, but that's just like the simple version of it. And here is like the actual implementation just for your reference. And with Amazon Bedrock, basically I'm calling out that I need to input my model ID here. I could always swap these model IDs as well for anything new that's come out, or maybe I want to use a specific model for this workflow. And it's very simple, straightforward. You invoke the model command, and then you process the body, and then you return it. You do any error handling that you need to do. So that pretty much covers the entire agent pattern. If you want more resources on how to implement this, I will be adding more resources to my Skool community and even more around the roadmap that I covered a couple of videos back. If you haven't seen that video, you can go watch it here. But essentially, this is going to be week 6 of the entire process. So I'm going to cover this in a lot of depth. You're going to get the code, you're going to get guides, extra videos to go over these topics just to help you out when you're working on these projects on your own. Maybe you have a client project coming up and you're like, oh, this is a good pattern I might be able to use. So go ahead, hop into that community, and you can get all of those resources there. And of course, you can ask questions as well. So as you're working on the products that you have, or maybe some client work or a project that you're working on, you can ask questions in this community, talk directly with me, and I'll be happy to kind of help you out and get through some of those humps you have. So I've been working with agents for a few months now, and I think I'm at the point where I can build things. I feel confident about building things reliably. I think the next step up is to actually put out some commercial products. So I'll be kind of documenting what I'm doing on the commercial side, more so in this community than on YouTube, and going over the nitty gritty details and really hopping into code bases and getting into all of the strategies and tactics that I'm using as well. So grab this, and if you have any questions, feel free to DM me on this platform too.